Tired of this क्या हुआ? चलो मैं तुम्हें गिनती बताता हूँ। कंधार से शुरू करते हैं, पहलगाम तक चलते हैं। 1999 कंधार बीजेपी की सरकार, 1999 कारगिल युद्ध बीजेपी की सरकार, 2001 संसद अटैक बीजेपी सरकार, 2002 अक्षरधाम अटैक बीजेपी सरकार, 2002 और 2017 अमरनाथ यात्रियों पे अटैक बीजेपी की सरकार, 2002 गोधरम बीजेपी की सरकार, 2016 पठानकोट हमला बीजेपी की सरकार, 2016 उरी बीजेपी की सरकार, 2019 पुलवामा बीजेपी की सरकार, 2025 पहलगाम बीजेपी की सरकार। तो जब बिहार, बंगाल, केरल और अन्य राज्यों में चुनाव आते हैं, घटनाएं अपने आप घटने लगती हैं, नया कुछ भी नहीं है। लेकिन ये वीर गाथाएं बीजेपी के राज की, कंधार से लेकर पहलगाम तक मुझे गर्व के साथ कहना पड़ रहा है कि बीजेपी है तो मुमकिन है। 1999 कंधार, 1999 कारगिल, 2001 संसद अटैक, 2002
Everyone, am I audible? Please confirm in the chat so that we
Yes.
can. Thank you. Let's quickly start. Session 7, which is VM provisioning. Share my screen. Hope the presentation is visible. So
Yes,
today's
sir.
topic is virtual resource management and cloud provisioning, how VMs are provisioned on both cloud, public cloud as well as private cloud. So agenda for today's session, for contact session 7 is going to see about VM provisioning, how it is managed, and what are the process, and what are the migration services we have, hot and cold migration, and migration techniques, provisioning, and migration. Let's directly get into it. So two core services on IaaS model on both public and private, which is VM provisioning and migration services. So provisioning a VM, it's like spinning a VM on both cloud and what is that? Private cloud and public cloud. So you can do that in a few minutes, and you can save a lot of time and effort. Migration also can be done in milliseconds, which saves time and effort, similar to spinning a new VM and making the services up and live, okay, without any disruptions. So which gives you SLAs and SLOs agreed, okay, for the business without any effect on the existing services. So historically, like how you install a VM means that you install a new server, how you provide that server as a service for various clients, what are the efforts taken by the administrator, and what time it takes for you to launch a VM and give it to the end user for them to use. Okay, so here we have four steps. One is your inventory on your mission and get one from that inventory. So based on the configuration. And then what you do formatting of the hard drive, and you'll install operating system, whichever is required. It could be Windows or Linux. And you need to install the services after that. Okay, you need to install patches, security patches, appliances, drivers, etc. So with respect to virtualization technology, it differs a lot. Okay, in traditional way, all these four steps are important, but in the virtualized infrastructure, it is slightly different, and it gives you, it matters you in minutes, like you can achieve launching a VM. So if you see how the VMs are based on the virtual machine in terms of virtual machine on physical host. So at the right hand side, you could see you have all those configuration earlier, like let's say VM1 has a particular OS and particular application, whereas VM2 has a different OS. Okay, so from there, you will be picking one and you will be launching it on the respective host. Okay. As you will be working on a private cloud infrastructure as well as on a on a public cloud infrastructure. In public cloud, we will not know how it really happens, but it happens through software-defined data center, whereas in private cloud, it is directly through hypervisors and all your what is your vSphere infrastructure. So if you see, you will be picking the VM images from the repository. Okay, and the provision manager, what he will do, through him, you can launch a VM on the respective host or any of the hosts, which is where you can see in the diagram. So if you see provisioning a VM in the public cloud, you can take EC2 instances or Azure VMs, okay, or Google Compute kind of a VM. Whereas in virtualization management software package, okay, let's say you have installed that on a private cloud infrastructure. That is, you have your own data center and you have installed that in your data center where it manages large, what is that? VMs can be grouped together and you can install it on the respective server. So as you can say, you can migrate physical servers, like coming to the migration services analogy. Okay, how earlier it was being performed. Okay, you can see like any upgrade you want to do, any maintenance task you wanted to do. Okay, there is a lot of time and effort. Okay, because you need to restart the operating system. Okay, and upgrade your device driver, or you need to attach a disk, or you need to your RAID controller itself has a problem. What happens is you have to switch off your machine and all your VMs on top of that will go down or your server will go down. Now it is completely different and it is completely revolutionized due to virtualization technology and the migration services. On top of you can see you have a physical server and you have a what is that virtualization done on those physical servers. So you'll be moving one VM from the server one to server two. That is what earlier we did. Now what happens is that you have all those migration services are associated with the hypervisors. So hypervisors are capable of doing all those tasks, okay, on a live infrastructure. Like you see, you have to do maintenance tasks, you need to upgrade, you need to put upgrades on the software, you need to have device driver patches or security patches, okay, you can easily do it because everything is grouped and everything is shared as you can see in the diagram given below. So you'll have vSphere hypervisor in both the what is that infrastructure where you can move host here and there based on your need. So here you can differentiate. So virtualization can be defined as you all know it's an abstraction of four computing sources. Let's say storage, processing power, which is your compute, and memory, and finally your network communication, which is your IO. So you can see the diagram like left hand side and right hand side how it differs with respect to a single OS owning the complete hardware resources, whereas multiple operating systems sharing the hardware resources in terms of virtualization. Okay. Now revisiting the virtualization technology. So if you see the virtualization layer, uh, it shows you all underlying physical server, okay, which is resources which it uses, okay, and into multiple virtual machines. So you can see under the virtualization layer, you will have scheduled resources, and you have allocated physical resources. Okay, so it allocates physical resources, and it makes each virtual machine think that it is an independent one. Okay, and that the underlying processor belongs to that virtual machine, and it makes it visible and easy to manage resources. And the next one is it improves the utilization of resources by multiplexing many virtual machines on a what is that, one to one on a single physical host. Okay, these machines can be able to scale up and down on demand based on the utilization of resources because it is completely abstract, right? And it enables high reliable and agile deployment mechanism. And also it provides on-demand cloning. You can clone that VM and you can create a new VM. Yeah? And also you can do live migration, moving your VM from one physical host to another physical host, which is already available in your public cloud. Let's say you're on a particular physical host, your VM is not performing well. What you can do, you can move you can move your VM from that particular host to another host level migration you can do, which even AWS or Azure provides the same. And having efficient management suite for managing virtual machines. Management suite in the sense the user interface for you to access all the VMs under the control of your purview. Now you can see in this slide the virtual machine provisioning and manageability lifecycle. Okay, so this cycle starts by a request delivered to the IT department stating that you need to create a new server. Okay, for a particular service to be implemented, or you need to launch an IAS, or the host website. Yeah, this service will be processed by the IT administration, and by seeing the servers in their resource pool, and they'll see whether this match is there in that respective resource pool, so that they can provision you with that virtual machine. The third step is they will start the provisioning of the requested virtual machine. Once the provisioning is started, it will provide you the required service. So according to the SLA, let's say 99.999 provided by the cloud, public cloud. And then the next is once you want to deallocate it, if you could see in the diagram. So you'll be requesting it to the IT based on the analysis, and they'll provide you based on what OS you want, what kind of disk you want, etc. And then the VM will be operational for you. Later on, if you don't want the VM, you can just shut it down. Once you shut it down, your resources will be deallocated. Okay. Only thing is the disk will be still the same. Okay. Your volume or the disk, hard disk, or the premium SSDs will stay there, and other resources will be deallocated on that particular host, making the other VMs in that host can utilize the resources. So from the configuration part, you can see, right, you can create a VM builder. You can discover on the existing VMs how many VMs you have created. Okay, you can check the version control, when it is created, what configuration it is, and you can check those configurations Okay, as well. So once you deploy it, you'll be having it on the deployment part, like it is maintained by the development of the production infrastructure. Later on, it will be monitored continuously. And management is like you want to clone it, or you want to change the location, or you want to remove it, you can destroy it. This is the virtual machine provisioning and manageability lifecycle. Next is the provisioning process. So steps to provision a VM. First, you want to select the server from the pool of available server. Let's say in public cloud, what we will do, we will have the list of servers. Let's say 2-core CPU with 4 GB RAM, or 8-core CPU with 8 GB RAM, like that. Okay, so servers along with the appropriate OS template. And once you the specifications are selected, let's say uh, you have the OS template. Let's say you want to select Ubuntu 20.46.43 version or 16.16 version. Okay, all these things should be selected, and then you have to provision a VM. Okay, and then you load the appropriate software. Customize once it is launched. Customize and configure the machine. Let's say you have to provide IP address. You want to set up the internet gateway, whether it is exposed to the internet. You want to set up a public IP address if it is required for you to host a web application on top of the VM. Okay. And the storage resources, let's say you want 128, what is it, volume of GB, or what is your size requirement for your VM to run. Okay, all these things are ready. And then your VM will be, your virtual server is ready to start. And with all these OS selected, will be loaded and it will be ready for you. This server provisioning is by defining the configurations, as I told you, right? Based on our requirement or the organization requirement. So VM can be provisioned by, you can manually install OS. You can use a pre-configured VM template. Okay. And you can clone a VM from an existing image. Let's say already you have a VM running. From there also you can take a clone. As I said, you can also host a server from another hosting platform. And finally, physical servers can also be virtualized and provisioned using physical to virtual migration. That is what P2V migration. Let's say you are having a physical server with a single hardware, you are running a single OS. Even cloud provides you certain softwares where using that you can copy that a VM taken as an image and you can move to cloud infrastructure and there you can convert that into a virtual machine. So after creating the virtual machine by the virtualization of a physical server or by building a new virtual machine of it or from a template, you can just create it out. So most virtualization management vendors, you could see various vendors. You have VMware, Zen Server from Citrix, and you have Hyper-V from Microsoft. So they provide data center administration with the ability to, as an administrator, to do all these tasks. When provisioning from a template, which reduces the time, okay, in order to create a virtual machine, you can just take a template and you can launch it. Template will have all the options like what OS it has to be, what are the configurations you need to set. Directly you can launch it. So administrators can create multiple templates for different purposes. One is for memory-based application or a normal application to be launched. Example you can see here. You have a tool here. What is that? This demonstration I'll give you in the next session. As of now, we'll move. After this, Vagrant is a provisioning tool. Okay, using that you can provision VMs. Next is your virtual machine migration services. So we have different techniques. Okay, so in terms of VM migration. So because when you move your VM from one host to another host, you have to follow certain techniques. As I told you, like hot or cold migration. Hot or live migration means the VM will be running. Okay. Cold means you can switch off the VM. Live storage migration of a virtual machine. So all these three techniques can be applied. So all key machine components, let's say the CPU, storage, disk, networking, memory, are completely virtualized during this process. So if you're going to migrate from a physical machine to a virtual machine, the physical machine where you have the configuration, right, that will be taken as an image and that will be stored in the, you can take a copy of that, move to your virtual environment and you can launch a same configured image. Let's see the migration types. So migration can be categorized as cold or live migration, basically two types. Okay. So cold means non-live migration and live migration. Based on the granularity, you can, what is that? The migration can be divided to single or multiple migration in terms of phases. So what is the major need of this is you can have the continuous optimization and improvement of live migration techniques by reducing the downtime and because if you don't want your application to go down due to migration, or example, like you can take you're having a highly what is that customer facing infrastructure and you don't want to give downtime at any stage. Okay, so downtime is nothing but the interval. This which needs for you to start the migration service. During that time, you will not be able to provide the services available to the customer, and there won't be any synchronization. So for a single migration, migration time refers to the time interval between the start and the pre-migration phase to finish the post-migration phases until your host is moved to the destination. So on the other hand, the total migration time of multiple migrations. Okay, so multiple migrations in the sense you will have a start time where you started the first migration and where you completed the last migration. All these intervals will be grouped together and you can take it as total migration time of multiple migrations. Coming to live migration and high availability. So coming to the live migration, so which is also called as hot or real-time migration. So now we're going to the movement of virtual machine from physical host to another host. When the machine is being powered on, your machine will not go down. The machine will be still running. So how this is being carried out? Okay. So it will be carried out in a matter of milliseconds. So what are the advantages of live migration? As I told you, right, there is what is that? There is it facilitates proactive maintenance in case of failure. So usually, if you do this, what happens is your potential problem can be resolved before any services got disrupted. How they will do is they will also use the load balancing facility, okay, which will be shared among computers in order to optimize the utilization of available CPUs. Let's say during fraction of second, your resources will be shared across through the load balancer so that your actual migration can be carried out without any choking of resources. Let's take a look at this diagram where you have migration triggered as step one. Now you have a target task to be scheduled, and the source VM is running. Okay, you can see the source VM is running, and you have created a task, right? So what the task is, you need to set up a target VM. So that is what is your task. So at the same time, during the source VM is being executed continuously, you have set up a target VM. Okay, and you start the migration. Okay, you'll authenticate to the respective VM, and the source runs while the migrating on the state. So your migration will be started, and it will be receiving the packets from the source to destination. Okay, so it will be receiving and restoring the VM state. So it will coordinate the VM migration throughout the phase. After that, what happens is once the VM is restored at the destination part, okay, the VM will be resuming to run from there without any disruption. It is like the source will be running, and once the destination VM is ready, there will be a transitioning of state. Okay, like handover. So until then, the VM will be running, and all your resources will be responded from the source VM. Once this VM is ready to resume the action, what happens? The source VM will be passed at that state, and here it will be resuming the activity. Once it has started the resume activity, it will it will receive the request from the destination from the user end, and the new VM will try to support. At that stage, the source VM will be passed. Okay, and then what will it will do? It will stop the source. source won't work after that. After that, the target will start running as the migrating process. It is still in the migrating state. Okay. And then it will notify to that VM that is uh, the, uh, the completion of migration is done. So that the migration complete task, and it will be updating the network. After that, your task becomes visible. So it is that you have been completely migrated from the source to the destination. So you can see a pre-migration brownout duration at the bottom and the blackout duration. Okay, where the pre-migration brownout duration is nothing but the data are sent from source to destination. Okay, when the VM is still running in the source. Okay, in the blackout duration, the destination VM will start running, and what is that? The source will be passed at that stage. So steps of line migration mechanism. So how memory, virtual machine states are being transferred. Let's say they are in running state, right? Through the network from host A to host B. You see an example like you have Zen hypervisor from Citrix. So what they do is the migration process has been viewed as transactional interaction between two hosts. It is like two hosts which is working, two physical hosts, let's say server, a physical host, which will give that handover control to the destination. So now you can see the live migration technique. So in stage one, it is pre-migration. So active VM on host A. Okay. Alternative physical host may be pre-selected for migration. Block devices mirrored and pre-resources maintained in the alternative physical host. Okay. In stage one reservation phase, initiate a container on the target host. Okay. And now in the stage two, iterative pre-copy will be done. Now enable the shadow paging. Shadow paging in the sense the memory or the data which is stored in the respective source will be copied, and those it will be done on a successive round manner. So copy dirty pages in successive rounds. Okay, at the stage 3, stop and copy. Suspend the VM on host A, generate the ARP request to direct traffic to host A. Okay, and then what it does is it does synchronization of all remaining VM state to host B. Once the data is copied during the overread during the copying, and then what happens is at stage 4 it commits, stating that VM state on host A is released. It means the copying is completed, and with all the remaining state of the host A. Okay, and the host A state, let's say at the time it is running some information that will also be copied in the configuration file that will be sent to host B. Okay, and then what happens is the activation takes place in the stage 5, wherein the VM will start on the host B and connects to the local devices, and it resumes normal operation. So in round one, how the shadowing is done. So paging concept comes under your memory from hard disk to hard disk, how data are copied. So all your pages will be there in the main memory. Similarly, those pages from main memory will be sent to the pages of the destination host. That is what is shadow paging. Whatever images you have, they will take a shadow similarly to that. And they will start copying one to one. You can see orange color, right? That will be copied to the respective shadow in the destination host B. So it means whatever state is being maintained in host A, for that respective VM will be copied to the destination host, same to same. Next is your pre-copy migration round 2, which is an iterative part, right? You can see the orange colors have been completely move the data wherever you want to move, right? Those things will be moved accordingly in an iterative. So dirty pages in the sense the white dots. Okay, later on the full portion of the image will be copied from host A to host B. Okay. And in the final round, you will stop and copy the remaining parts from host A to host B. Only 4 blocks are pending. Is moved to host B. So phases in migration. Okay, you will have a push phase, stop and copy phase, and pull phase. So memory and storage transmission can be categorized in these 3 phases because you what is that? Theoretically, what we say is we say it is copied from host A to host B. Okay. So two hosts, right? Two VMs only. You're going to like from one VM, you're going to migrate that VM to another part. So here, what actually matters is the what is that? Your physical memory and your storage. So that is what you have separate phases for that, which is a push phase where the instance is still running in the source host while the memory pages and the disk blocks. Okay, those things are written onto the destination host through network. It is right. A copy which is currently running will be moved from the source to destination system. You like the same copy, only the minor stages at the last second, what changes it has happened in the main memory or storage, that will be moved and it will be stopped here and it will be started from the destination. So stop and copy phase. So now if you see, once the push phase is done, whatever live buttons are there, that will be moved. Next is stop and copy is the last one. So if you see, your instance will be stopped for a few seconds. At that time, the memory pages and the disk data is copied to the destination through the network. Okay. At the end of the phase, the instance will resume at the destination. This will be happening only in very few seconds. It will take milliseconds. Okay. At that time, the source will be stopping its activity, and the final, it is like final backup, incremental backup. Right? Like that will be pushed. After that, the pull phase. Once the copying is completed, the pull phase where the new instances execute while pulling faulted memory pages. Okay, it is like some memory pages are not being read, is not got updated on the source during shutdown. Okay, those pages, those unavailable source pages will be retrieved and it will be sent to the host. That is what is pull phase. Now you can see the live migration image taxonomy, which is taken from the prescribed book. So now you can see the pre-migration where you initialize and reserve the resources. And what happens every time frame you can take during the total migration time, you have T0, T1, okay, and then the T1 again by the blackout time. Okay, so if you see iterative copy, iterative pre-copy will copy the data, this gray portion. And then the stop and copy is what we saw right here, the stop and copy phase. And then where during the downtime it will be copying. It is very minimal number of time. And after that, it is like all data is copied by doing the pull. Okay, that is what this block. And after that, is post migration and activation, where you do whatever post override you have, that will be taken care. So pre-migration and post-migration phases are handling the computing and network configuration, final stage. So during the pre-migration phase, the migration management software creates an instance interface, okay, on the destination host and update the interface, and it does port binding, network management software, all these things to be done. So it can be done by using the OpenStack Neutron server, and it configures a logical router where it has to communicate. Okay. And during the post-migration phase, again, the migration management software updates the port or the interface states, at what state the interface is, whether it is communicating or it has completed the communication, and rebinds the port with the network management software. And this instance virtual interface, that is VIF driver, which unplugs the instance virtual port on the source host. Okay, so that from that instance, the communication will happen in the destination port. So one more diagram how it is done. So we have introduced phase by phase, what is the topics with respect to reservation, iterative pre-copy, and after that we started with stop and copy, and finally commitment. So pre-migration process, you can see PM active on hosted, destination host is selected, and block devices mirrored. Okay. So what is block devices mirrored is, let's say, so you will be having two identical copies of the data on separate block devices for redundancy. That is what they will do. Okay. So they will select a destination host. They'll keep the copy of the source, the same copy in the destination also. Like in RAID 1, we will do. Okay. So like volume mirroring, you would have studied in Linux, right? It's the same concept only. So here you will call it as block device in a sense. You will have a device like buffer. Okay. Let's say it is like some other partition in the hard disk where you'll keep that copy. So even this block device is used for performance. If you take virtualization concepts, they will attach multiple block storage devices. Okay, and they will set it up for mirroring. Mirroring in the sense they will keep a copy of the same data. If your VM goes down, from this mirrored data, they'll take the VM and they'll make it up. That is what they say. They provide you with the SLAs. After that, initialization container on the target host. Initialize. That is the reservation process. Okay, in this VM, sorry, in this host, this space is blocked such a way that you give the host. After that, you do copy dirty pages in the successive runs. So to keep you more explain to keep you informed on the dirty pages. Dirty page is nothing but a memory page. Okay, that has been modified in the RAM. Okay, what happens is right. You have not modified how RAM and secondary storage it will work, right? So when you want to execute some program, it will copy the data from the secondary storage. Your application will move that the data from the secondary storage will be moved to the physical memory. From there only, it will be sending it to the CPU for execution. So that part, right, the updated one, which is there and residing in the main memory, which is called as data page. Okay, means that it doesn't have a sync between memory and the disk. So usually what OS will do is they'll have cache memory, right? There they'll keep it for frequent accessing. So once the dirty page is copied completely, all the other pages will also be copied. The committed pages will also be copied on successive runs. So after that, they will come to a conclusion, right? Okay, this data is completely ready for us to copy. During downtime, it will be copied. That is what stop and copy. So suspend the VM on the host A and then redirect the traffic. And then what you do, sync the remaining state. So whatever is not updated on the current state will be updated now. After that, you can commit. So committing means you now activate the host A because you have already stopped the VM on uh, the host A, right? Now you can start the VM on the host B and you can release the VM state. It means that you can just destroy the VM. That is what is understood. Okay, let's have a short break now and continue. Any doubts? Let's resume. So still we continue. So post-migration code runs to reattach the device drivers to the new machine. Okay, and provide them the what is that, the IP address changes, right? You can use the same IP address which is there, which you have been using in the host A. Okay, so this approach is to failure management ensures that at least one host has the consistent VM image at all the time during the migration. So some disturbance should not happen right during a migration. So if you see what are those two steps, the original host remains stable until migration commits. Okay, and the VM may be suspended and resumed on the host with no risk of failure. So that's what is stopped. Okay, if something goes wrong at the either end, so if you see a migration request essentially attempts to move the VM to a new host, and on any sort of failure, execution is resumed locally and aborting the migration, so that there isn't any what is the disturbance to the host or the source area. Okay, so challenges of live migration. If you see, VM has lots of state in the memory. For example, your memory pages are updating, keep on updating every few minutes. Okay, which will be really challenging. It will consume more time as well. Some VMs have soft real-time requirements. That is also one of the live migration challenges. So live migration effect on running on a running web server. Okay, you have a web server. Okay, let's say Apache 1.3 web server that is running on that particular VM. And a static content at a high rate. Throughput is achieved when continuously serving a single 512 KB file to a set of 100 concurrent clients. Let's say 100 concurrent clients, one behind the other, they are accessing or they are requesting to this server. Okay, in that duration, what kind of data transfer happens? That is what this diagram is all about. So this web server is serving multiple 100 clients, and during that time only, you're doing this migration. Yeah. So there are a lot of VM management and provisioning tools that provides live migration of VM facility. One such as VMware's vMotion. It automatically optimizes and allocates an entire pool of resources for maximum hardware utilization, flexibility, and availability. It performs hardware maintenance without scheduled downtime, along with migrating virtual machines away from failing or underperforming service. Next is Citrix servers, Citrix Zen server. Citrix is a vendor, and they also have ZenMotion. So based on Zen's live migration migrate utility, it provides our administrator to facilitate them to move a running VM from one Zen server to another in the same pool without interrupting the service. Okay, they confine that there isn't any downtime at all. So making it highly available service and also good feature to balance workloads on virtualized environments. Next topic is cold migration. So cold migration is again, migration happens during the VMS powered off. And with cold migration, you have options of moving the associated disk from one data store to another. Okay. So virtual machines are not required to be on shared storage. So if you see live migration needs to be to a shared storage of virtual machines in the server pool. But cold migration does not do it. Okay. So in live migration, you need to have the live migration of VMs happen between two hosts. There should be certain CPU compatibility checks. Okay. Whether the source VM CPU and the destination VM CPU are similar. Okay. All those checks will be happening. Whereas here it does not apply. Whole migration in using VMware product is easy to implement and it is summarized as follows. What happens is the configuration files, including the BIOS setting, which we call it as NVRAM file, log files, and the disk of virtual machines are moved from the source to the destination host associated storage area. Okay, from the source storage area, the data will be moved to the destination because it is switched off state, right? You can have that data on, you can move it and you can switch it on. So virtual machines is registered with the new host. And after the migration is completed, the old version of the virtual machine is deleted from the source source. So you can see VMware Cloud on AWS. Okay, is an example scenario which we're going to see. So VMware Cloud on AWS uses the same VMware SDDC stack. Okay, so software-defined data center stack that customers were using on-premises to leverage existing tools and skill sets without the need to invest in new resources. Okay, so here workload mobility of mobility, so that you can move your workloads from on-premise to cloud and cloud to on-premise vice versa. A diagrammatical representation like how migration happens between a vCenter server, like one host to another host. Okay, you can see based on the color like warm migration, live migration, cold migration, and content led. So if you see on left hand side is your on-premise data center, and right hand side you have your cloud infrastructure from AWS, which is also having VMware infrastructure, so that only your VMware to VMware migration happens. Okay, see content library, it moves all your VM images from on-premise to cloud. Okay, and then even storage from your normal storage, it is moved to virtual SAN storage area network. So here all your VSS, VDS cold migration, right? You have switched off your VMs and those images can be moved to your cloud infrastructure. So here you call it as your on-premise cloud, right? Which is vSphere will have a vCenter, which is your on-premise cloud and let's say private cloud. At the right-hand side, you can see software-defined data center where you are moving your data to a software-defined data center. It is also a cloud, but you have a centralized console where you can organize anything. So now let's see. Cold migration, you have a considerable downtime, right? Involved because you have stopped the VM and moved over to the VMware cloud on the AWS, and then you have restarted VM over there. So in order to perform a cold migration, you still need, okay, or you will need to have a hybrid linked mode configured between your on-premise infrastructure and your VMware cloud on AWS. Okay, let's say you need to have a direct connect communication, okay, between both infrastructure. And optionally, you can also use VMware HCX for performing the cold migration. So VMware HCX is a hybrid cloud extension. Okay, so you have a you can simplify the application migration, workload rebalancing, and business continuity. So usually where we use this is when we want to modernize your data center, we want to move VMs to a newer vSphere. Okay, a lot of versions will be there, or you want to make a cloud adoption for your business. You are already in on-premise infrastructure. You want to move it to cloud. So it is recommended to use cold migration for applications that accepts downtime. Okay, you can use web test environments or your Type 3 applications which are rarely being used. It doesn't require downtime. What is that? And uptime all the way. Okay, you can use it. Next is warm migration. Warm migration is there is low downtime during migration. Okay, that is we call it as warm migration. In this type of migration, VMs are replicated to the cloud. Then you can schedule when you want the VM to actually switch over to the cloud. Okay, again, this requires restart of VM, but downtime is just for few minutes. Here also you can use the VMware's hybrid cloud extension vMotion with vSphere application. Okay. So it is recommended to use VMware migration for this warm migration for bulk migration scenarios where you want to migrate 100 VMs together. Okay. And for the application which are moderately being used, not being the previous part is rarely used. This is moderately being used and has very accepts low downtime. Live migration, we all know. Hot and live. So the VM is switched off, is not switched off, sorry. Okay, and then the live migration happens from on-premise to cloud. But you have few prerequisites, okay, which you should enable it before starting the live migration to your software-defined data center. Okay, the primary requirement is this: you should have a hybrid linked remote configure. So this HLM is which will give you a single view across both on-prem and cloud. Okay. So you'll get unified view across whatever host you have on both the ends. That is what is you need to set up. And then you should have L2 VPN, okay, layer 2 VPN enabled between your on-premise environment and your SJDC cloud. Okay, and then you need a speed of 250 Mbps bandwidth as per vMotion. Okay, so although live migration seems to be a more attractive option, but we should consider the amount of data to be migrated. So what data you have here, and based on that, what bandwidth it takes, and the latency issue. If you have a large amount of data, you will not be able to do live migration. If your VM is having some 4 TB of data, what you will do? Okay, this will definitely affect the duration as well as the cost of migration. Data transfer is really cost. So there are two types of hot migration. One is on-demand hot migration. One is planned hot migration. Okay. So you can use vSphere's vMotion or the VMware's hybrid cloud extension vMotion. Two application utilities are there. And then, as I told you, right, you have direct connect options for better speed and enhanced security. There is a feature called direct connect. Let's say if I'm in Chennai, I can connect my data center. I have an internet, right? So my internet provider will give me a direct lease line connectivity between my data center and the cloud infrastructure data center. That is what is direct connect. Yeah. And then next is planned hot migration. You can use VMware's hybrid cloud extension vMotion with vSphere application. Application in the sense you can start replication by today and you can frequently have data transferring over the period of time. Okay, and then you can, once the replication is completed, you can start with migrating of VMs. So it is highly recommended to use hot or live migration for mission critical applications where downtime is not acceptable. So this is content library importers. You can reprovision VMs from the scratch using the content library. Okay, you can publish your VM images onto the content library. Okay, from on-premise environment. From there, you can move those data to AWS. Okay, it is like moving your data to the library like images. From there, you can move to on your what is it? So as I told you, right, like ISO images, library files like ISO or OVF, yeah, cloud enabled images can be created and you can store it there. From there, you can pull those images, create an instance on cloud. So this method is really useful when you want to copy the existing content from on-premise to cloud and then provision the VM. So future directions, self-adaptive and dynamic data center. So means that it should be more intelligent, automated, and completely cloud. So it has to self-adjust, okay, on the resources, policies, and operations based on the workload demands or business requirements. Okay, we used to call that as self-healing. Okay, it should detect the failure and reroute the workloads automatically. Should do. So that is what is self-adaptive and dynamic data center. Few examples, mostly policy-driven. Okay, so example like if you have a CPU usage spikes on a critical VM, they should automatically scale up by creating a new VM, and it should use a load balancer to maintain the load accordingly. The dynamic data center means you need to rapidly allocate, move, and reconfigure resources. So as we say, like elastic thing, right? Like scale up and scale down, and software defined. That is what you need to have that agility. Both self-adaptive data center and dynamic data center should be provided. So performance evaluation and workload characterization of virtual workloads, high performance data scaling in private and public cloud infrastructure, performance and high availability in clustered VM to live VM migration. You can use multiple algorithms, okay, when you schedule a VM. And accelerating VM's live migration time. So you can reduce migration time so that you can have better migration task has been completed. Live migration security. During your migration, you should maintain security. So you can even check these videos. Now you can take up the quiz. Any doubts? So I'll try to give you one sample migration as either in private cloud. Earlier, I was working for a data center. We were managing a data center where I was owning few VMs and I did some migration very long back for the existing batches. Now I'm not a part of that organization. I came out of it. Anyways, I will try to bring some images from those VMs, how VMs are consolidated. Okay, how the consolidated view will be. Okay, on a physical host, what will be, how many VMs you can host like that. I will show it in the next session. I'll try to show. And we'll also try to do some migration, some small VMs here and there. Next session will be your practice session, right? Like your there, I will show you then. Okay. Any queries? Any doubt? You can take up the quiz now. Please take up the quiz. So I've already uploaded this presentations in your Teams folder. And please check and revise it over there.